Hi, hello, good morning, good afternoon, good evening, whatever time it may be that you're watching this. This is still the great teacher Alcantara, and this time around, we're back for new lessons, and we are now starting with what we call as the special products. So, the first special product that we're going to factor in this video is in relation to perfect square trinomials. And with that out of the way, let's just jump right into the lesson. So we're now going to discuss factoring perfect square trinomials. But the first thing that we need to establish is that you should know what a perfect square is, or what are perfect squares. So for us to continue with this lesson, it's important for you to remember where we get these terms. So the perfect square or perfect squares, it actually originated from the idea of squares, because again, the name is squares. And what's with squares? We know that squares have four equal sides. And that's an important detail for us to remember. Each side of this square is equal to itself. And the formula in getting the area of the said figure, which is a square, the area of this, some of you may already know this, is side times side. And since this is the formula of getting the area of a square, we can solve for side times side, knowing now how the product law works. Like if you have the same variable or the same base, simply copy it and then add the exponents, so you will have s raised to 2 or s squared. So we have established that square is, the area of it is s times s or s squared. And thus, perfect squares copy or somewhat embody the same idea of s squared and how you get the factors of it. As you can see, s and s are the same thing, similar with the examples that we're going to deal with in this lesson. So let's start. So for the first part of our drills, we will focus on perfect squares. The perfect squares that we will focus on here are mainly numerical numbers, or basically integers. I'm showing here two sides of the perfect squares. We have the positive and we have the negative. And the reason why this is a drill is because it's something that you need to be used to, somewhat memorize, somewhat remember the rules of it, and this will guide you as you continue with the lesson. For example, 1 squared, we can write that as 1 times 1, and the product here is 1. We can have 2 times 2 for 2 squared, that is equal to 4. Next, we have 3 squared, 3 times 3, that's equal to 9. We have 4 squared, that's 4 times 4, that is 16. We have 5 times 5, that is equal to 25. 6 squared, 6 times 6, we can have 36. 7 squared, that's 7 times 7, we'll get 49. 8 squared, 8 times 8, that will give us 64. 9 squared, 9 times 9, that will give us 81. 10 squared, that will give us 10 times 10 equal to 100. Okay, so what I'm showing you here in your screens right now is the given, which are squares of a certain integer and its factored form and its product. The product that we get when we multiply the number by itself, 1 times 1, for example, 2 times 2, we call them as perfect squares. Okay? Because as you can see here, we multiplied it using the same number, like 1 and 1, they are the same. 2 and 2, they are the same. 3 and 3, they are the same. And so on and so forth. So when you multiply a number to itself, this one time for squares, you will get a perfect square. Like 1 times 1, 2 times 2, so on and so forth. Because if you multiply it or use it as a factor like 3 times when it's raised to 3, those are cubes na. In the meantime, we're focusing on squares. So basically, we're using it as a factor twice based on the exponent. And as you can see, the answers here are all positive. Similarly, if you have negative 1 raised to the power of 2, so you have negative 1 times negative 1, that's positive 1. Negative 2 times negative 2, that will be equal to positive 4. Negative 3 times negative 3, that will give you positive 9. Negative 4 times negative 4, that will give you positive 16. Negative 5 times negative 5, that will give you positive 25. Negative 6 times negative 6, that will give you positive 36. And negative 7 times negative 7, that will give you positive 49. Negative 8 times negative 8, that will give you positive 64. Negative 9 times negative 9, that will give you positive 81. And negative 10 times negative 10, that will give you positive 100. Always remember, class, if you are raising a number or an integer, whether positive or negative, and the exponent is positive, like 2, 4, 6, 8, 10, 12, whatever it may be, the result will always be positive. Kaya pag negative yung integer mo, raised to the power of 2, raised to the power of 4, laging positive yung sagot dun. Okay? In the meantime, we're focusing in squares. So as you can see here, we have arrived with the same answer for 1 squared and negative 1 raised to the power of 2. They're both positive 1. What I'm trying to imply here is that perfect squares has two sets of pairs of factors. You have the positive version and you have the negative version. Okay? This will be important for you to remember as we move forward with factoring perfect square trinomials. There will be times wherein we need to use the positive factors, and there are times that we need to apply or use the negative factors. Always remember that factoring is the inverse of multiplication. So basically, if you have the perfect square 9, the factors of that is 3 times 3, or 3 and 3. It can also be negative 3 and negative 3. Okay? So that's what perfect squares are for. Next, how about if we are dealing with perfect squares in relation to monomials or variables? So we have here a set of examples, and actually not all of them are perfect squares, and we'll see about that. So for a squared, we can say that this is a times a, and we already know the product is a squared because that's basically it. We can also have a cubed, or a squared times a. That will be equal to a raised to 3. We can also have a raised to 4 as a squared times a squared. That will give you a raised to 4. A raised to 5 is a raised to 3 times a raised to 2. That's a possible set of factors. That will give you a raised to 5 still. A raised to 6 can be a raised to 3 times a raised to 3. That's a raised to 6. A raised to 7 can be a raised to 4 times a raised to 3. That's a raised to 7. A raised to 8 is a raised to 4 times a raised to 4. That will give you a raised to 8 still. A raised to 9 is a raised to 5 times a raised to 4. That's possible, so a raised to 9. And next you have a raised to 5 times a raised to 5. That will give you a raised to 10. So among all of these examples, not all of them are perfect squares. The only perfect squares that you can have here are the ones in which the pair of factors are the same. So if you notice, we have a times a, that's for a squared times a squared, that's for a raised to 4, a raised to 3 times a raised to 3, that's a raised to 6, a raised to 4 times a raised to 4, that's a raised to 8, and we have a raised to 5 times a raised to 5, that will give us a raised to 10. So the important thing for you to look at in here is actually the exponents of the given. So we have a squared, a raised to 4, a raised to 6, a raised to 8, a raised to 10. So what we can conclude here, if we are dealing with monomials, we can say that any variable, for example, or any variable to be exact, example is a raised to 2, if the exponent is, so what can you notice with 2, 4, 6, 8, 10? These are all even numbers. If the exponent is an even number, it is a perfect square. You can factor it. But there are some restrictions in here at times, so that will be explained better once we have actual examples. So we have a squared. This can be a perfect square because the exponent is positive. That's an important detail to remember. Okay? And next part of our review, let's have a recall of multiplying linear binomials. So we have a lot of recall or things that we have to recall in order for you to understand perfect square trinomials better. But bear with us because this will help you in making perfect square trinomials just a matter of patterns. Earlier it's filled with drills, and here we have another recall, but afterwards it can be smoother as long as you remember the process. So here we can have different ways of multiplying linear binomials for us to get perfect square trinomials in this given. Why are we getting perfect square trinomials here or our lesson? Because we have here two binomials that are the same. X plus 2 is the same as x plus 2. X minus 2 is the same as x minus 2. So the process that we can use in multiplying these linear binomials is what we call as the FOIL method. So how does the FOIL method work? The first thing is the F. It is about the first terms. The outer terms for O, the inner terms for I, and the last terms for L. So basically, it's an application or a reinterpretation of the distributive method. So if you look at the two binomials, x here is the first term of this first binomial, and the x here also is the first term of the second binomial. So multiply those two. So we can see here, x times x, that will give us x squared. The outer terms, nasa labas po, x and 2. So basically, x times 2, that will give us 2x. Next, 2 times x for the inner terms, that will give us 2x. And for the last terms, 2 times 2, that will give us 4. And the next thing that we have to do here is to simply combine them. So x squared plus 2x plus 2x plus 4. And since we can still simplify 2x and 2x, we can still add them. Our final answer here should be x squared plus 4x plus 4. This right here is actually an example of a PST or a perfect square trinomial. From the definition again, we have, my spelling of trinomial is incorrect. Trinomial. Again, it's a perfect square because we have the same factors, x plus 2 and x plus 2, and at the same time, the result is a trinomial. That's why it's a perfect square trinomial. That's how you define it. You don't need to overcomplicate it. Similarly, you can have here x times x, that is x squared. Outer terms, negative 2 times x, that's negative 2x. Inner terms, that will give you negative 2 times x also, negative 2x. Then negative 2 times negative 2, that will give us positive 4. That's what I've been talking about earlier. Like, as you can see, the last term is positive, but the middle term will be negative. That's why it's important for us to also consider the negative factors of positive integers. So as you can see here, we can still combine negative 2x and negative 2x since they are like terms. So this will be x squared minus 4x plus 4. And this also is a PST or a perfect square trinomial. So for us to fully understand this, we can actually have a pattern that we can use in order for us to really or fully embody the lesson. So we can have here the following: a plus b multiply to itself, a plus b also. Similarly to the other side, the quantity a minus b times the quantity a minus b. So it's a good thing also for you guys to review how to multiply variables. So let's say we have the first terms, a times a, this is it, that's a squared. Outer terms, a times b, that will give us ab. B times a, that will give us ab also. Then b times b, that will give us b squared. So altogether, this will be a squared plus ab plus ab plus b squared. You can see we can still add the middle terms here. So we'll have a squared plus 2ab plus b squared. This will play an important role later on. For now, let's continue. A times a for the first terms, we'll get a squared. A times negative b for the middle term, that will give us negative ab. Negative b times a, that will also give us negative ab. And lastly, negative b times negative b, that will give us positive b squared. Altogether, this will be a squared minus 2ab plus b squared. So as you can see here, the middle term is negative. Here, the middle term is positive. So that's why it's important for us to remember that there are two cases when we are dealing with perfect square trinomials. Okay, to continue, we are now ready for the actual lesson. So for perfect square trinomials, it is important for us to identify whether the first and the last terms are both perfect squares. And the middle term is twice the product of a factor for the first and the last term. Okay, don't panic about this. This will be much easier once we start with an actual example. So let's proceed. Let's say we have y squared plus 2y plus 1. So the first step here is that we should determine the first and the last terms and whether they are perfect squares. So this is our first term right here. This is our first term. We have y squared, and here we have 1 as our last term. It's important to remember the drill that we had earlier. Yes, we made use of the variable a, like a squared, a raised to 4, a raised to 6, and so on and so forth. But whatever variable we use, b, c, d, even any letter in the alphabet, as long as it is raised to an even number, like this, it is a perfect square. So therefore, we can say that the factors of y squared, I'll write it here so that everyone can see it, factors of y squared is basically y times y. The next thing is 1 as our last term. And since everything in this given is a positive term, the thing that we're going to consider for factors of 1 is its positive factors, which is basically 1 times 1. Now, there's a thing here saying, for step 2, verify if the middle term is correct by using the formula, middle term is equal to 2ab. Sir, how does the 2ab work, or the formula itself? So there is a pattern earlier that we solved for in the binomials. It's a squared plus 2ab plus b squared. So since a is the base, that implies that the a is the y. While for the b squared, it's the one of the factors of the last number. So how does that work? To put this in a much easier perspective, when we're applying this formula for the middle term, simply get 1 each. So to get the middle term, it is equal to 2ab, wherein we can use a as y and the b as 1. Therefore, this will be 2y times 1, that is 2y. And as you can see, the middle term here satisfies the formula's answer, which is 2y also. So this means that the given is a perfect square trinomial, or a PST. Since it is a PST, we can now put it in its factored form. So therefore, I'll just rewrite it so that everyone can see it. Y squared plus 2y plus 1, factored form is a plus b. Don't panic. What is the a plus b? Just get one of them. For a, it's y. For b, it's 1. And since it's a perfect square trinomial, just copy it. It's the same thing. And that's it. That's your final answer. So what do we mean by check if you obtain the correct answer? All you have to do is to apply the FOIL method, like y times y. That will give you y squared. Next is the outer terms, y times 1, that will give you positive y. Inner terms, 1 times y, that will give you positive y. Then lastly, 1 times 1, that will give you positive 1. Altogether, this is y squared plus 2y plus 1. So since this helped us arrive with the same answer, that implies that our factored form is correct. And at the same time, If you remember earlier, we had like 1 squared is equal to 1 times 1, something like that. Because it is also important to take note that the factored form, which is the quantity y plus 1 times the quantity y plus 1, can also be written as the quantity y plus 1 raised to the power of 2. Following the same logic that we have discussed earlier, this could also be a possible answer. To make this clearer, let's test out the step-by-step guide for our next example. Let's say we have here, identify the factors of x squared plus 7x plus 16. Again, first step, let's identify if the first and the last terms are perfect squares. And since everything is positive, also consider the positive factors for the last term. So for x squared, we know that this is x times x. While for 16, this is 4 times 4. But before we go to the third step, it's important to verify the middle term. So if we do that, middle term is equal to 2ab. So let's just get one of the factors each, x and 4, for this formula right here. So 2 times x times 4. 2 times x is 2x times 4. That will give us 8x. Here, pay attention. It says here, wait, I just lost my voice there. It says here that, yan, we're back. It says here that the middle term should be 8x. But in our given, it is 7x. Therefore, this given right here is not a PST. I repeat, this is not a perfect square trinomial because even though the first and the last terms are perfect squares, the middle term does not satisfy the rules. So if you wish, you can do it like this. You can try to factor it. Like, for example, sir, I tried. We can factor it naman, x plus 4, and multiply it to itself, x plus 4. But if you apply the FOIL method, let's try FOIL method right here, for the checking whether it's correct. X times x, that is x squared. The outer, x times 4, that is 4x. The inner, 4 times x, that is 4x. And the last term, that is 16. If you add all of this is equal to x squared plus 8x plus 16. Meaning to say, you can only say that this is the factors if the given is x squared plus 8x plus 16. So basically, what I'm showing to you guys is an example of identifying errors. In some exams, we call this as error analysis. We can say that 7x is the error of this given problem. How do we know? Because we tried and looked for the middle term using the formula, and we also did checking. Okay, so we did two ways here. We did the formula for the middle term, and we also did FOIL method for checking. And both of them shows that it's supposed to be 8x, not 7x. That's an important example for you guys to understand. To continue, so what if the given is actually x squared plus 8x plus 16? Let's not make this complicated anymore since you already know the answer here. It's x times x. This one is 4 times 4. We already know that the midterm or the middle term, if you substitute it to 2ab, this will be 2 times x times 4. The answer here is 8x. So therefore, since it's correct, we can simply factor it. So the factors are as follow. The quantity x plus 4 times the quantity x plus 4. Or, we can say that our answer here is the quantity x plus 4 raised to the power of 2. And that's it. What I'm showing you guys here is that there are two possible ways of writing your answers or your factored form. It can be two linear binomials, or it can be in a square form, like a perfect square form. So that's it. Let's proceed to another example. This time around, we have x squared plus 12x plus 36. Same case, x squared, that's x times x. 36, that's 6 times 6. To continue, middle term, 2ab. Again, for the middle term, just choose 1 each. So 2 times x times 6, that will give you 12x. So therefore, it's correct. We can proceed to factoring or step 3. So this will give us x plus 6 times the quantity x plus 6 also. And we can also write this as the quantity x plus 6 raised to the power of 2. As simple as that. Perfect square trinomials are basically, if you know perfect squares, whether the variables or the integers, it will no longer be difficult. It's a matter of getting used to it, of the patterns, and that skill will help you out in making perfect square trinomials easy. Okay? It takes time, so don't panic. Just remember, it's always important to try and try and try. To continue, what if the middle term now is negative? It's negative right here. Okay? So therefore, let's look at our first term, x squared. That's a perfect square. 9 is also a perfect square. Since x squared can be factored as x times x, how about for 9? Now the dilemma is the middle term is negative. But don't panic. Remember what we have discussed. That 9, a perfect square, can have two versions of factors, the positive and the negative. Therefore, we can say that the perfect square factors of this 9 right here is negative 3 and negative 3. Negative times negative will give us positive. And if you do the formula for the middle term, 2ab, just choose 1 yet again, 2 times x times negative 3. 2 times x is 2x. 2x times negative 3, that's negative 6x. As you can see, we are still in the correct path, but this time around, the factored form or the factors are as follow. The quantity x minus 3 times the quantity x minus 3, or we can also write this as the quantity x minus 3 raised to the power of 2. So this is what I've been saying earlier. There is the positive and there's the negative side of it. Just like all of us. There's positive sides of us, there's negative sides of us. That's for valuing, I guess. But this time around, let's have one more example, I think, or two more. We still have two more. Now this one is a combination of all the lessons so far. So we have to look for x raised to 4 and the last term 25y raised to 4. Don't panic. Again, look at the exponent. It's raised to 4. That's an even number. So therefore, we know that this is x raised to 2 times x raised to 2. So again, it's still a perfect square. Now, sir, paano to? 25y raised to 4. Don't panic. Do this step by step. 25. Is 25 a perfect square? Yes. Since the middle term is negative, what version should we focus on? The positive factors or the negative ones? Well, since it's negative, the factors that we will consider are the negative. 25y raised to 4. 25 can be factored out as negative 5 times negative 5 because our middle term is negative. Afterwards, you still have the y raised to 4, and we know that y raised to 4 is also a perfect square. So y raised to 4 is y raised to 2 times y raised to 2. So that's how you do it. So basically, if you multiply negative 5y squared to negative 5y squared, the answer there is positive 25y raised to 4. Okay? Continue with the middle term. The middle term, we can have 2ab. So choose 1 lang. Choose 1 here. So this will be 2 times x squared times negative 5y squared. Take this 1 by 1. 2 times x squared, that's 2x squared. To continue multiplying it, this will give us negative 10x squared y squared. And that's our middle term right here. So we can proceed with step 3. So this could be x squared minus 5y squared, and we'll multiply it also to x squared minus 5y squared, and you can also write it as x squared minus 5y squared, that quantity raised to the power of 2. And lastly, our example here is 9a squared minus 6a plus 1. Same case with earlier, 9a squared, that can be factored as 3 for 9 3, 4, 9. For a squared, that's a. This is a. Middle term 1, since the last term is 1 and the middle term is negative. So therefore, we're going to consider the negative factors of 1. Continue, middle term. That will be 2ab. Just choose 1, 2 times 3a times negative 1. That is equal to negative 6a. So that's correct. Therefore, the factored form will be 3a minus 1, the first one, that quantity times quantity 3a minus 1, or the quantity 3a minus 1 raised to the power of 2. And that's it. That ends our lesson with perfect square trinomials. And that ends our discussion in relation to perfect square trinomials, factoring perfect square trinomials to be more specific. For our next few lessons and videos, it will focus on the other special products, mainly difference of two squares, sum of difference of two cubes, sum and or difference of two cubes, and after that we'll be dealing with some word problems and we'll be done with factoring. And in case you don't hear from me or you don't see me, always remember, good morning, good afternoon, good evening, and good night. Always know what's up. Respect. Peace out.